number 26, Chupacabra number 26. In 22, 23, 24, we covered a whole lot of stuff after I've gone back and looked at all that. This one I'm just going to touch on some of the things, clarify some things, reiterate some things on those. 25 was the quarter century one on design ideas. While I'm thinking about it, left one little detail out of that. Don Hardy that I talked about in 25. My high school English teacher, Miss Jeter, was so proud of me for requesting those study hall passes to go to the library. She thought I was really well, I was really educating myself, but what she didn't know was that the high school library had a subscription to Carcraft magazine and Hot Rod magazine, and I look forward to getting those every month. Shout out to my old buddy Neil Britt, former editor of Carcraft magazine. And on to this one. Got finally my earwig thing here, my NCIS deal. Now that we know that it requires a battery charge as well, I think we finally got our audio issues cleared up, and I'm going to go over some things that kind of were interrupted by audio on these last ones. Got my cheat sheet here, but battery's charged up, and I think we got this finally figured out. Again, just to kind of clarify some things, these were the tubes that I ordered for all the A-arm stuff. This is a particular length. You saw the pile of scrap in the floor. When you put this thing in a joint jigger, there's certain places you can put it and can't put it, and you got to allow for all that to know how big to make them. But out of 14 of these, which is about 30 feet, there's maybe 3 or 4 feet of scrap. That's pretty dang good. This is DOM tubing, pretty thick wall stuff. DOM is drawn over manual. That's as opposed to ERW tubing, which is very common. That's electric rod welded. Electric rod welded, it starts as a flat piece, it gets wrapped around, and the seam is welded together. That seam causes a bump inside the tubing. When you try to put a spud in it like that, the bump won't let it go in. Besides this stuff being a lot stronger, a lot nicer to TIG weld for the A-arms, you don't have that bump in there. You can file it out, you can work it out, but it's just a pain. So what little extra that deal, plus when you're bending it, especially on a real tight radius like that, you don't want that ERW seam busting. But that's why we see how that spud just goes in there so nice and easy. So another thing on these brake lines, what I wanted to show you. Every bit of that brake line is flex line. That is not an issue with performance. It is not an issue with DOT rating. But here's what happens. If you get the whip that goes out here typically, and then that goes into a hard line, well, there's only a foot or two of hard line. There's got to be flex line up there. You know, we showed you the pedals. There's got to be flex line up there for that. So now you've got what amounts to 3 more whips up there, and you got this much hard line in the middle. Kind of a similar deal here. You got the whip here, and you got this much hard line in the middle before you go to that. Well, that hard line is going to require a fitting on either end of the hard line and a fitting on either end of the flex line to go into it. So if you just add a little extra flex line, you eliminate a whole lot of fittings in this whole deal, a whole lot of potential leaks, a whole lot simpler. So that's what we've done on this, and that's why this entire thing is flex line, is because with that needing to be flexed, with this needing to be flexed, you just got this little piece of hard in the middle if you wanted to do it, and you don't want to do that. Come back here and show you this carpet that we ripped out the other day. I've got the new gray color as opposed to the black color carpet put in. I haven't put that seat belt back in the seat yet, but I'll show you that. Got both seats in now. Come around here, I want to show you. Come right to the front of the car and look back here. This kind of a interesting, cool look. That bug catcher will be exposed through the back window. There's a plenum there that shows that. I've just set this woofer speaker in place here. It's going to be in the center console top enclosure. but you can see the relationship of that woofer and that and so forth, and it's kind of starts to make a very, very cool looking detail there. I'm extremely pleased with that. I said, misspoke in one of those videos that the steering column was a RPC copy and a I Did It copy. Let me clarify something. That is an RPC column. I Did It and Flaming River are the people in the hot rod industry on steering columns and steering and so forth. That's an RPC column. Some people may or may not know, the first generation RPC columns had a whole lot of slop in them and they were pretty worthless. It's kind of scary when you can do this with your steering wheel. The second generation was better, and the third generation, which is what this is, they finally got all that stuff worked out. I had even heard some stories that there was enough slop in there that the wires bound up and they caught on fire, and a bunch of stories like that. But at any rate, I tried to fix some of them for them, and it was a hopeless cause. And there's a bunch of spare parts from them that's all going in the trash can now. The new generation RPC columns I will put in a car of mine. The other ones were pieces of crap. But that's a $100 column. The competition is a $350 column. And now I don't believe there is any difference in the two. Speaking of the steering stuff, we talked about this before, the double D shaft stuff. That stuff comes in a 36-inch length. See, it's the flat spot on either side, that's why it's a double D. This one I've already cut some off of, but you cut this stuff, put the U-joints in, just like we've done on this here, but goes in, makes whatever. And again, it's just a very easy way to make a steering system that every component is designed to work. With the other components, instead of trying to put this manufacturer's joint into that manufacturer's slip into the third manufacturer's number of splines and all that, it just goes on. It's done. Double D, RPC columns. We talked about that relay that the high beam, low beam switch here on the stalk is only rated at 3 amps. Well, relays are a very cool thing. Basically, a relay, you can send a little bit of power to something. It closes a gap and connects two much heavier wires. When you have something like a horn that's got little bitty wires going up here, and you need a much thicker wire to make it work, like a fan relay, for instance. You've got a 12 gauge wire running to the fan. Well, you don't necessarily need that 12 gauge wire running anywhere. You can control a relay with a much smaller wire. Classic example, I guess, is a starter solenoid. If you didn't have that relay, that solenoid is a relay. If you didn't have that, you'd have to have aught gauge battery cable running up to your starter switch. It lets you do that. This is the wiring. You can see it's 20-something, 30 gauge, whatever. This is the wiring that works that eyebrow on that. And I said, really, we need a relay to work that wiring? The wiring that operates the relay is a whole lot better gauge than the gauge of the wiring it's controlling. So that's why we did away with all those relays. This thing draws a 1/2 amp. There's 2 of them. This is rated at 3 amps. Do the math on that and figure out why we can get rid of some relays. They're great when you need them, but we just simply did not need them on that. Show you something here. This is something that I was talking about when part of the video, the audio went bad on the video. I'm going to show you this again. A couple of things here. We talked about not grounding things and so forth. Well, this horn, that steering column's not grounded to anything anymore, and that's the way a horn works. So we've just put a riv nut in here and screwed in the stud and ran a ground wire from the column here to our grounding block, so that this column's actually grounded so the horn will work. The other thing I want to show you here, to make these pedals slide, that takes up a whole lot of space in a very cramped area here. To come up under here and grab these handles and slide these pedals back and forth, you've got to have room for your handles to work, room to grab them and so forth, and you actually need twice as much room for your master cylinders, because they move from here to here. So you got a great deal of area there that's open here, and it's kind of tough because the space is cramped under here, but we've been able to do it and get it real nice. One of the things we had to do, though, these vents kick 90 degrees and come out and up instead of coming straight back. I was getting in a bind there to get my ductwork up out of the way of this. I said, you know what, I bet Old Air's got something in their catalog. And I looked, and sure enough, they've got a 90-degree deal, so I ran down there and got a couple of those. That kicked it out of the way, got it way up away from those handles. Made me look like I knew what I was doing. I told them at Old Air, this thing makes it look like I planned it that way, and it's perfect. But got bailed out on a real design issue right there, and it just bailed out to make me look good. We talked about the cables from Azusa. We also talked about the stuff from Loose, L-O-O-S. Saw in the video, I didn't show you really well. This is a ball crimping tool, and it's a high-dollar little piece of equipment, but I'd much rather buy one from a factory that's ball crimped. And then this is a go no-go gauge. And once you've crimped it, you got to check for all kinds of certification and strength and all that. And it's just easier to buy a cable with a ball already on it. But one thing I do like about Loose, what I wanted to show you, talked about the lanyard deal. They make these little deals right here that'll also go in that ball crimp machine. And the cable goes in, comes around, goes back, and instead of putting a ball on the end of it, you can put a lanyard on the end of it. Can you see that all right? Mm-hmm. And that's kind of a handy deal, especially in some applications like in your doors and so forth, where you're getting door latches, stuff like that. The lanyard deal is kind of handy. And this Loose tool, we'll put those on as well. Oh, I want to show you, we talked about cutting those Hayco deals with a wood bit. Come up here, let me show you something. Put together a little demonstration for you. This is just a piece of 60 thousandths aluminum. That's my 1/2-inch wood bit. Watch this. See how that's cutting that? See, as opposed to a metal bit that just chews it up. See how that popped it out? See that? See that? See that? Made a real nice clean hole in aluminum with a wood bit. Now if you're gonna, what is that, a squirrel? Good thing the dog's not around. This is a nice way to make a hole in aluminum, but if you can get to the edge, this right here, I've always heard it called a Roper Whitney punch, but I guess we'd have to call this one a Harbor Freight punch. But this is a way to cut holes in
14.5
minutes. Well, we'll make a third video out of this. This is a way to cut holes in aluminum, or sheet metals. And hole. And hole. Call it, and we'll cover some more in a second.